So here is our sketch, correct? Now prior to this we've usually dealt with how many lines per Cartesian plane or per plane? One. And the reason we do that is because we don't want to get muddled up. But we can have as many lines on a Cartesian, on a plane as we want, can't we? It's really powerful to know when these points cross over. And the reason that's the case is because it allows us to identify, for example, in a financial context, if you're joining a gym, who's familiar with gyms and how they operate? Okay, what happens when you rock up to a gym, Harry, and they make you sign a membership? What normally happens?
Usually I have to pay something.
You pay a joining fee and then you have to pay a weekly fee, correct? Happy with that? If you were to join a gym which had a higher joining fee and a lower weekly fee, it'd be a good way to compare the two and say which one's the best option for me. Should I take the $50 joining fee and $10 a week, or no joining fee and $15 a week, or $12 a week, or whatever it happens to be? And you could identify the exact time period where it was financially better to do that. Sweet? We can do that in a couple of ways. Now these are some pretty wild examples because they're crossing over. If I want to know where they collide, what can you tell me about the point where they collide? I want you to have a think. Think about these two lines, and I want you to think about what happens when they collide, when they run into each other. Laura, what do you think happens when these functions run into each other?
They're the same value.
The same value. What's the same value?
1.
They're both 1. X equals 1. What else is the same about them? What does y equal? So for this function, what does y equal at that point? What does y equal at that point for this function? Sorry, what does y equal on x equals 1 of the blue function? What's y equal for the black function? So what do we know about these functions when they meet? Both y and x for both functions are the same value. Correct? Now we can do this graphically. We can say, hey, look, that identifies there. Do we need to draw these functions? Do we need to? Is there a way of looking at our equations? Because these are our equations up here. Is there a way we could do it without drawing? What do we know?
You could let either x or y equal 0.
Only because I know where it is already though, don't I? What does y equal when x equals 1 for this function? 0? What about this function? So couldn't I say, if I know that these y's equal the same thing, because that's what's this crazy, what are these two lines? What do they mean? Equals. What is, I've never done math before. I don't know why I'm in this class, but what does equals mean?
That the two values are the exact same.
The two values are the same. So I could replace one of them with the other and it wouldn't matter, correct?
Yes.
That's what that means. They're exactly the same. So, what about these? If they're both y's, what are they? Exactly the same. So couldn't I write, would I be within my rights to write x minus 1 equals to negative 2x plus 2? Would that be okay? Or have I done something wrong? Let me know if something doesn't make sense. Ethan, do you think that makes sense or not? Am I allowed to do what I've just done? What do we do if I say let y equal 7? What do we do on the next line? Normally, we let y, we substitute the y with So if I know y equals 6, can't I put that in the equation where there was y? Am I allowed to do that? How many variables do I have left over here, Riley? How many variables do I have left over here? I've got x minus 1 equals negative 2x plus 2. How many things don't I know in that equation?
Well, technically 1 and 2.
What are the things I don't know?
X.
What's the other thing I don't know?
2x. Well, yeah.
But if I know 1x, don't I know 2x?
Yeah.
So how many things don't I know?
Well, there's two of them, but it's the same thing.
Yeah, very good. So I am playing a little bit of a mind trick on you here. I've got x's on both sides, but the only thing I don't know is x. It's the only unknown. So what do I do when I'm faced with an unknown?
You rearrange.
I rearrange to get it by itself. How do I deal with x's on both sides or unknowns on both sides?
Take away the smallest x value.
Take away or add the smallest x value, depending on what we've got. That might be a little hint. Which value is bigger? 2x or minus 2x? Sorry, x or minus 2x? X. So I want to go to take them to that side because I like dealing with positive numbers. How do I get rid of minus 2x, Victoria? Add 2x to both sides. I'm going to do this in blue just so it's a bit... What happens to the minus 2x on this side and the plus 2x? What's x plus 2x? 3x minus 1 equals? What do I do with the minus 1? The 1's on the left. 3 equals? X equals? That's interesting. What happened at x equals 1? That's where they collided, correct? Do I know the y value? Remembering, I've never seen this graph before. It's blanketed from my memory. I've got one of those things from Men in Black which removes your memory. You've got no idea what's going on here. Do I know my y value? No. I don't know it yet, do I? But I know my x value. So what could I do? Mason, do you have an idea about what I could do? Looking only at the left side of the board. I could sigh and think, Jesus, period 5, Mr. Beddington. On a Friday, give a man a break. But that won't help me. No clue. What do I know about x? What do I know about y? Don't I? I know nothing about y. What do I know about y? I know something about x. I know it equals 1.
Y equals x. Y is 1. No, y equals x plus 2.
That's what I know. You know what else I know? Negative 2x plus 1. Plus 2, sorry. I know both of those things, correct? If I let x equal 1 in one of those equations, does it matter which one? Both equal the same thing. I'm just going to pick the easiest one. Which one looks easier? The bottom or the top? The bottom. So on x equals 1, and a y equals x minus 1. So what could I write that as? Y equals? Okay, 2 steps slower for the rest of us, Harry. Y equals? You're right, but slower. So y equals x minus 1, correct? What do I know about x? It equals 1. So I can write y equals 1 minus 1. Where'd the red one come from?
Yeah.
The fact that I know that x equals that. If I found that to be x equals 7, what would I write in? 7 minus 1. Sweet. But in this case it's 1. Y equals 1 minus 1. What do we reckon that is, bro? Harry was good. So tell me what's significant about the points 1, 0. Where does that occur? When the two lines collide with each other. Sweet. This is called simultaneous equations because these lines hit that point simultaneously.